Okay, so this is just building on what we've already done. So it's a 4-step process. You're going to first state the parameter you want to estimate and the confidence level you're looking at. Plan, identify the appropriate inference method and check conditions. If conditions are met, do the math, then interpret. That's writing out that long sentence, filling in the blanks we've been doing the whole time. So, we have this problem here. Sleep Awareness Week begins in the spring with the release of the National Sleep Foundation's annual poll of U.S. sleep habits, and ends with the beginning of daylight savings time, when most people lose an hour of sleep. So in the Foundation's random sample of 1,029, remember, that's our N, U.S. adults, 48% reported they often or always got enough sleep during the last 7 nights. We're going to do a 95% confidence interval to see about those people who said often or always. So, what are we looking for? We're looking for the true proportion of U.S. adults who answered or said often or always got enough sleep. Any way you want to put it. True proportion of U.S. adults who said often or always got enough sleep. Slept enough. Got enough rest. Just the general gist. Not going to grade on the order of the words or which synonyms you use. Just as long as you get the general gist that we're looking for the adults who said they got enough sleep, usually or all the time. That's what we're looking at. That's what the study is about. Now, what's our plan? Well, we got to check for P and N. So, as I heard, 0.48 is our P hat. Okay? 1 minus P is going to be 0.52. Okay? So 48 cents for candy, 52 cents for change. That's the analogy we're using. Now, we're going to take both of those times the number of people that were asked. 1,029. 1,029. That's going to give us 493.9 and 535.1. Both of those are clearly way over and above 10, so check. We're good to go. We're way above what we need. Okay? So now we're going to do the math. We're going to do the formula. So the formula is, we take our p hat, a 4.8, plus or minus. Now, our z-score is based on our confidence level. The confidence level is 95%. The z-score that goes with that is 1.96. Then we put our p, 1.48, 1 minus p, 0.52, and the number on the bottom is our 1,029. So, baby steps. I type in my calculator, big square root symbol, and I just type in 0.48 times 0.52 divided by 1,029, hit equals, and then multiply by the 1.96. And that gives me 0.48 plus or minus 0.03. That's rounded. So my range is from 0.45 to 0.51. 0.48 minus 0.03, 0.48 plus 0.03. And then in conclusion, we just write our same old statement. So we are 95% confident that the true proportion, or the interval, sorry, that the interval first from, you just plug those numbers in, 0.45 to 0.51 represents the true proportion, same thing every time, represents the true proportion of adults who said, oh, they slept enough, basically. Got enough sleep often or always. I don't know what to do with the board is it won't pull up. Again, as long as you have the general gist of the statement, I'm not going to be grading the specific words. We're 95% confident that the interval from 45 to 51% represents the true proportion of adults who said they got enough sleep often or always. All right. So, sometimes we need to work backwards. Sometimes we're going to work backwards to find what the sample size needs to be if we want to be within a certain margin of error. So, look at this problem. It says, recall from a previous example, in another day, the GSS found that 31% of Americans reported they were very happy. Suppose the designers of the GSS now want to estimate the proportion of all adults who are very happy with a 99% confidence interval and a margin of error no more than 0.02. How many people do they need to ask to fall within those guidelines? So, 0.02 is our margin of error. So if you look up here, that's this, right here. Now we're just going to fill in the blank. Equal 2.58, and that number again is our z-score associated with 99%. Now we just fill in. We know it's 31%, so that makes 69% our change, and we're trying to solve for n. So we're just going to use algebra and work backwards. All right? So what do I have to get rid of first to get to my n? And I can't square root yet. Good. I need to get rid of the 2.58. So I need to divide both sides by 2.58. Okay? That cancels this. That gives me a decimal, it's rounded because it's really long, of 0.0775. Now, what do we have to do to get it by itself? Already heard it, we got to square both sides. If we do that, that gets rid of the radical. Now, I need you to see what happens on your calculator when you're doing this ever in class. If I do 0.00775 squared, look what I get. The E does not mean error. We talk about this all the time in Algebra 2. The E is not error. That's the calculator's way of saying scientific notation. That's the calculator's way of saying times 10 to the negative fifth. So all that means is we're going to take this number and move the decimal 5 places to the left. So if we have 6006. I rounded this. The decimal's here, right? We're going to move it 1, 2, 3, 4, 5 places. And where there's an egg holder, drop in an egg. That is 0.0775 squared. Tiny number. Equals 0.31 has 0.69 is 0.2139 over n. Now, if you remember, maybe, from geometry and trig, remember sometimes you had to find, like we were doing logarithm, or not logarithm, we were trying to find like the sign of something, and the letter was on the bottom, and you're trying to do the unknown, and you're trying to solve for that. The technical long way is, you have to multiply both sides by n, and then divide both of these. But the shortcut is, these two just swap places. That's the shortcut. So n is equal to 0.2139 divided by 0.00006006. That's the shortcut. You just switch the n and that number on the other side. Because technically, you multiply both sides by n, which would put the n right here, then you divide by this decimal to get n by itself. You can save yourself time by just doing that. And what you get is n has to be 3561.4. In other words, they need to have 3,561 people in the survey to fall underneath a 2% margin of error. All right? Now, let's say you rounded up to 3562. It still wouldn't matter. Either way, you get 0.019999. So either one of those falls within the realm. Tomorrow you're getting candy. Anybody allergic to Hershey's Kisses? Okay, so you're going to get those tomorrow. Okay, so we're breaking this down into the same steps. So first off, how many kids, 8 to 18, have a TV in their bedroom? Okay, it says 71%. So that's our p hat. 0.71 and 0.29 is our 1 minus p hat. We're going to multiply both of those by 2002. Okay? 2002 is the two, not the year, it's the number of people randomly selected. That gives us 1421.4 and 580, that looks like an 8, 580.6. Both of those are greater than or equal to 10. Check, we're good to go. We have satisfied large numbers requirement. So, same formula, 0.71 plus or minus. We're doing a 99% confidence interval, so again, that's 2.58. And then we do our 0.71 times 0.29 divided by 2002. I type into my calculator, square root, 0.71, 0.29 divided by 2002. Hit equals, it's going to be a real tiny decimal, multiply it by 2.58, and I will get plus or minus 0.03 this time. So what's my range? 0.68 to 0.74. So, based on the interval, is there convincing evidence that the majority of 8 to 18-year-olds have a TV in their bedroom? Well, we have a 99% confidence, okay? And the range is 68% to 74%. Yes. So, is that a majority? Yeah. It's a pretty good amount. It's pretty safe to say that most 18 to 18-year-olds have a TV in their bedroom. Now, it says if the researchers want to reduce the margin of error at most 1%, how many more people would they need? So we're just going to do it backwards, like we just did. So 0.01 is our margin of error. We don't want anything more than that. 2.58 is our z-score. 0.71, 0.29, and this is an n. We're going to do the same thing we just did on number 1. We're going to work backwards. So when I divide by 2, I'm not going to show it, divide by 2.58, I get 0.00387 equals 0.71 times 0.29 divided by n. How do I get rid of the radical? I square both sides. Again, on my calculator, it's going to give me that E negative. So it's going to give me 1497, but E to the negative 1, 2, 3, 5 again. 1, 2, 3, 4, 5. So 0, 0, 0, 0. 1497 equals 0.2039 over n. And then the shortcut I showed you, the more work you show me, the more I have to grade. If you don't want to show the work and you make a mistake, it's all or nothing. If you show me the work and make a mistake, I'm going to give you partial credit. So it's your choice. I'm not going to mandate it. You choose how much to show me, but you help me help you, the more you show. So you switch places. Remember this little trick. 0.2039 divided by 0.12340, 1497. And that gives me an n, that's an m, not an n. That gives me an n of 1,375 students. Now, I'm just going to show you this real quick. This is not required. It's just a little technological advantage. So, you follow along in your instructions. If you go to your calculator and hit stat, and you go over to tests, the instructions will be in here, and you go to A1. Cool. Guess I'll just do it here. You go to A1. Right there. And you hit enter. You can put in X and N and change your level and see if you got it right. So my X for this one would be 0.71 times 2002 for the 71% of them. Now here's the thing. You can't put a decimal in here. So you just got to go up here and get rid of the decimal part. N, we said, was 2002. This was a 99% level. And then you hit enter, enter. And it gives you your range. So 71% is what we had. 68 to 73. It's just a way on the calculator you can verify what you already did mathematically. It's up to you whether you want to use it. Real quick, I copied down some wrong when I did this. When you divide here, you actually get 13,754. I missed a number when I wrote it down on my calculator. So that makes way more sense. There should be way more than the previous 2002. Okay? So it should be 13,754. This is right here. This part is right, but that yields that answer, not 1,375.